Hey everyone, welcome back to the channel. You've probably already heard about the rise of autonomous AI agents. I explain what they are in another video. Today, we are diving into something that could be really game-changing: MCP, Model Context Protocol. I will introduce you to MCP and explain why I and many others in AI space believe it could become the future standard for enabling agents in interact with the world. There are already some incredible agent frameworks out there like Longchain, AutoGen, and Crew AI. Developers are constantly building powerful custom solutions. But as more and more agents are created, a real challenge is starting to show up. It's becoming too complex to connect all the different functions built using different frameworks. That's where a common language or protocol becomes important. MCP is not about replacing an agent's internal logic. It's about standardizing how agents communicate with each other and with regular APIs. Think of it as defining the plugs and the language they use to connect. When I was young, every device seemed to have its own unique connector. Phones, cameras, printers, you needed a specific cable for everyone. Today, you have USB-C for almost everything. It's becoming the universal standard for data and power across so many devices. In the world of IT, how do systems usually talk to each other online? Often through APIs. For many of you, REST API are probably familiar. They define a set of rules and conventions for how web services can send and receive data. Now, while you can call APIs directly in code, it can get repetitive. That's where SDKs come in. An SDK wraps around an API and gives you pre-written libraries, functions, and tools in your preferred language like Python or JavaScript, so you don't have to manually craft every HTTP request. It streamlines development. MCP builds on this concept. It aims to be the USB-C for AI agents development. It defines a standardized API specification for how agents interact with each other, with tools, and with clients. Alright, let's break down MCP itself. At its core, MCP involves a few key components. First one, MCP protocol. This is the heart of the MCP, a standardized set of rules, message formats, and communication patterns that both the server and clients agree to use. It defines how an agent registers, how tasks are described, how results are returned, and how errors are handled. Secondly, MCP client. This can include one or several clients, such as applications like chatbot or even an IDE. It implements the client side of the MCP protocol, allowing it to connect to an MCP server, send messages, and receive messages. And thirdly is MCP server, which provides a collection of tools focused on a specific topic or application, making them accessible to the LLM. The MCP client connects to an application server using the MCP protocol. In essential, any agent built by anyone, regardless of its internal logic, can potentially communicate with any other MCP-compliant agent through an MCP server, much like any USB-C device can plug into any USB-C port. Now, let's break down the case using an LLM model like GPT-4, Cloud, or Llama. MCP is the communication framework or protocol that agents use to coordinate. An AI agent, acting as an MCP client, typically uses an LLM as its brain for reasoning, planning, and generating content. For example, when you ask a question like, "Help me plan a dinner with my friend," the process works as follows. The agent retrieves the necessary tools via the MCP server, like database, API, or code, etc. It then sends a question to the LLM along with information about the available tools. The LLM decides which tools to use and send its decision back to the client in the blue line. The client connects to the MCP server to instruct the dedicated tool to execute the task. Finally, the result is sent back to the client, and the LLM may be used again to synthesize the final output before it's returned to user via MCP in the purple line. So, when building an agent using MCP standards, you will focus on firstly implementing the MCP client logic, like collecting or sending standard messages. You only need to do it once for all MCP servers. Secondly, defining the agent's specific capabilities. That means what tasks can it do. Thirdly, integrating the necessary tools, including calls to LLMs, databases, or other APIs, within the agent's internal workflow. This isn't just theoretical. People are actively building infrastructures and tools around these concepts. Let's take a look at Smithery AI. Smithery is an MCP marketplace where developers can list their own MCP implementations, and others can use them directly. On the website, you will find different applications like GitHub, Perplexity Search, etc. Let's use GitHub as an example. There are many available tools like creating or updating a file, searching repositories, creating a new repositories, etc. To use these tools, all you need to do is follow the installation steps on the right. For GitHub, you need to provide your personal access token, which I've already pasted here. Once that's done, you will see the MCP configuration command. I can simply copy this command and paste it into my local application built with Chainlit, which is a very powerful open source tool for building LLM-based chat apps. I will cover the setup process and show you how to use these tools inside an LLM application in my next video. Now, let's go back to Smithery and test one of these tools. I will choose Create Repository. Let's name it YouTube Video Test and hit Run. Now, if I check my GitHub account, the repository has been created. The API call works perfectly. In the next video, I will show you how to connect your own LLM application to these tools. So every time you generate a new prompt, it can automatically use the tools you've configured. Just one note, authentication differs depending on the application. This part is still hard to standardize, but big tech companies are working on it. Maybe one day it will all be unified as well. Now, for some really exciting validation that this concept of standardized agent communication is gaining traction on the highest levels. On end March, the OpenAI account tweeted about exploring standards of AI agents interoperability. They recognize the need of agents built by different people or companies to work together effectively. This is huge, no? When a major player like OpenAI signals that working on this problem, it strongly suggests that standardized protocol, potentially like MCP or something evolving from it, are indeed the direction the industry is heading. It validates the core problem MCP aims to solve. So let's wrap up. MCP represents a crucial step towards a future where AI agents aren't just isolated geniuses, but collaborative teams. What do you think? Is MCP an inevitable future for AI agents? Do you see any other challenges? Let me know your thoughts in the comments below. If you found this video helpful and want more deep dives into AI advancements, make sure to like, subscribe, and hit the notification bell. Thanks so much for watching, stay curious, and I will see you in my next video. Bye!